Yeah, so this presentation is it's presented as code quality and stuff revolving around that. And sure, I'll be talking about some of the things we do with regards to code quality and a way to do this with just a small segment of it via packages. The presentation will go through this in a linear fashion, but that's just the outline. And you, Jörg, mentioned that people might know GPower code from some of the repositories online. I don't think we have released much since actually our public packages are from 2014 or something like that, and we have evolved those internally, obviously, but haven't released much to the public since then. That will change. We're working on changing that. Just need to make some of this screen real estate smaller, I think. Just a second. Thank you. And not just some of our reuse packages, but also a tool that we call at the moment VIP Assistant. And all that I'll be talking about in a moment. Let me share my screen here if I can. Just the screen, perhaps. And then, yeah. So the goal of what I'll be presenting here, or what I'll be showcasing, is obviously via packages. We would like to be able to reuse stuff. Oh, don't need to use that. Perhaps I will. Yeah. We would like to reuse some of our code, or a lot of our code, so we can actually spend more time on developing the actual source files. Then when we spend more time developing the source files, we have a higher code quality, so we can trust our code more easily. We like our code to be more friendly, so that is managing versions. For instance, if we look at some of our reuse tools, I've installed a few of them here. For instance, we have a string package, version 1, and if I can get this, we have a version 2. Those should be side-by-side installable. They shouldn't force updates to code that use them. And when we develop software components that are isolated, that are single responsibility, we can develop that component in isolation, test that, and release that, and then forget about it. Just use it in our applications. And also we have dependency management, or traceability of our dependencies, with version numbers and isolated to each its own package. So it's easy to document and explain to developers and to our customers which components goes into this application or their tool, or whatever it is that we release to them, or that we release to our colleagues. One thing that I will show as well here, I will explain in much more detail what all this is about, is just to show it up front. Some of the benefits from this workflow is, for instance, debug packages and developer packages and dependencies. Those are just package configurations of the same source code. Let's see, just minimize those and open this one. So, for instance, if we have just a sub VI here from a reuse package, this creates a random string. This one here has some documentation. It says debugging is off and it's password protected. We can also see for all these VIs that we have here, they are automatically documented where do they live. So this one is from the string package of a certain version number, a certain build, when it was built, and so on, what configuration the build was. This one is with debugging off, and it's fairly lightweight. We build our final applications with these kinds of sub VIs or reuse VIs because they execute faster and they drag along with them a lot less clutter like unit tests and so on. But it also means that if we have something that we would like to debug into these VIs, we can't do that with this one. But I can install a different version of it. Another version still, version 2.0.1. But this one instead, that's a debugging package. It ends on 1 instead of 3. That's just a convention we use. If we have time, we can talk about that as well, the version numbers. But I can install this one. And nothing in our application changes. We typically don't even have to close LabVIEW or our projects. We have Package Manager takes care of this for us. So now, if I open the same VI, sub VI, I had it in my application. Now it says debugging is allowed. And we have some changes down here. It's just a different build number. It's actually a different VI. So now I can open this one and look at the source code and debug into it and so on. That's one of the benefits of doing this or having these types of packages. I was talking about code quality. This is an example of one of the sub VIs. It's the same VI. It's a malleable VI from our array package, array version 2. And it goes we spend a lot of time actually refining this reuse code. Obviously, if we find a bug, obviously, but also actually making them work in many different cases. So the code quality increases the more we use them. But if we have to recreate all this code every time we start on a new project or for a new customer, and what do we have, then it's a pressure to actually create some good code. There are a lot of details going into code like this. For instance, making a proper malleable VIs to handle all the types probably. In this case, for instance, we have some asserts out here. We have some nested type specialization structures that takes care of different types, different scenarios. It could be, for instance, a database package where we have many different types that goes into an interface that goes into a database, but that database could be different. So all these details, we work them out one time, and then we can reuse that code. And if we want to add a feature or fix a problem with the code, we can do that one time and immediately benefit from that all over the place, that we use this package, that code. So all that is probably second nature to all you guys that do software development. But how do we do that efficiently, and how do we actually allocate time to get this done correctly? That is what this presentation is all about. And I'll open the presentation and get started. Let me see. Yeah, so I will have the Teams window minimized. Just let me know if somebody has a question along the way, and we'll hopefully have time for some discussion afterwards as well. Let's see here. I have adapted this presentation just from a presentation we did a couple of weeks back. So it starts out just with the premise here: low cost equals high value. That is somewhat marketing speech, but it highlights what we are doing here. That we have very high value and combined with low cost of software. Low cost in development time by doing it in an improved workflow, so we're faster to done, and then we have lower maintenance. That's the low cost. So let's look at that. Oh, yeah, sure. Just a short introduction for the guys, for you guys that may not know me. My name is Steen Schmidt, and I'm CTO of GPower, a company I founded almost 10 years ago. Been working more than 20 years with LabVIEW, and have programmed in probably more than 20 different programming languages, most of them for industrial purposes. So in earnest, to release something that works. Today I program mainly in LabVIEW, but I love software and math. So those are my interests when I'm not reading books or just taking care of GPower. So what do we do? What do we use LabVIEW for? Well, we do systems where our software of choice is typically LabVIEW. Whenever we have instruments or hardware involved with it as well, it's from. Let me just have a laser burner here. For instance, LabVIEW applications inside products. It could also be the typical electronics testing, which LabVIEW is used a lot for. And then more specialized cases, like maybe testing a generator, in this case for a wind turbine. So a 200-ton generator test, which involves a very high range of different signals. It could be machine vision applications, monitoring running turbines, characterizing turbine blades with a camera that is tough enough to be monitored, to be mounted outside on a running wind turbine. So very high range of stuff we use LabVIEW for, and we actually deliver the same type of code for our customers as we use ourselves internally for our own products, and we have a high level of success with delivering also tools to enable our customers to provide or actually to develop higher quality code themselves. Why do we do that? Well, the industry we work in is very conservative. It's quite old and dusty, if we could say that. It's a bit less glamorous than autonomous vehicles and stuff like that, although that can be touched as well in this industry. But the industry as a whole is quite conservative. To move that, we must introduce systems engineering also on the factory floor, and that can be quite challenging at times. And then we also meet, which is a problem for all of us that like LabVIEW. LabVIEW is expensive, unmaintainable even. That is something we hear a lot, and it scares people away from investing in LabVIEW. Scares people away from developing or evolving themselves with LabVIEW, becoming better and more proficient with LabVIEW. So we try to help people work smarter with LabVIEW, to help ourselves be able to work with LabVIEW also in the future. That is, these are one of some of the things that drives myself and drives GPower to work smarter. Well, since we only have a limited amount of time here, I've just selected one case of modular software, which is a cornerstone of software quality, modular software and actually modular systems. But I've selected a case with VIPM, or actually VI packages in the LabVIEW IDE. But this talk is just the same if we're talking about deployment, for instance, with NI Package Manager or different packaging tools to a runtime system. It could also be system configuration of modular hardware, for instance. It's exactly the same discussion. But this one is LabVIEW, the LabVIEW IDE, and packages there for reuse. A couple of things first. Preconditions. Package technology for software is not a preference. I meet that sometimes. Well, we don't like it, we don't use it because we don't prefer to do it. It's actually not a preference. It's proven computer science. That's one of the problems in the LabVIEW community, is that computer science is not that grown into the people that pick up LabVIEW and use that. It is becoming a topic, has become a topic over the last maybe 5, 6, 7 years. But an interest, at least, you don't have to have an education in computer science, but an interest at least in it will help with making better code. Same with unit testing and source code control and stuff like that. It's actually computer science, and we can look at other software to get some good indicators of how to do stuff. And I know a lot of you guys are doing that already, and we need to keep push that and talk about it and find better ways. There are no definitives. We always learn, and stuff that was the best way of working yesterday might not be that tomorrow. But let's have those conversations continually. Then there is version numbering. It's quite important to have versioned your code, like documents and everything you do, so you can see what are the same component, the same revision of something, and what is a different revision. We use semantic versioning, like many others do, with the major version number signifying a breaking change. So for packages, for reuse, the same line of major version numbers are compatible with each other. You can upgrade and downgrade those without breaking any compatibility in your application. But if you change the major, or if you install a package with a different major version number, those are two different packages. They have the same package name, but they are two different packages. And they have the same name because they solve the same issue. They have the same single responsibility. And then minor version numbers for functional changes, and bug fixes is the patch number, and then a build number as well. We increment the build number for each version. So we start at 1 and then move up. If we change any of these 3 version numbers, we start over with the build number. I know some, and we did as well at the start, have an forever increasing build number. That is, we found that is quite unmaintainable, because you have to have knowledge about the entire line of build numbers to know what is the next build number. You actually have to manage those build numbers. And then an understanding of solid principles, not just for object-oriented design, but for all software development. At least single responsibility, and to an extent Liskow's substitution principle. But single responsibility is something to think about whenever you do software. It helps you. When I'm talking about a software component, it's not just a VI package. It's just a software component with a surface. That surface is your public API. And the software component should have a single responsibility. It does one thing, and it does it good. It's understandable. So that means it becomes usable, it's maintainable, and it works as expected. You will save a lot of time implementing and using that component in the first place. And as a developer, you spend less time maintaining that software component when it's understandable. Then it has to be sealed. not sealed like a class can be sealed in some programming languages, sealed for modification, but it must be self-contained, it must be compatible with those major versions, as I spoke about earlier, and it should be then replaceable, and it should be stable. Those are the keywords beneath the sealed term. So that's just a software component, in this case, a VI package. Single responsibility is many things. Well, if you look at like a computer application like Microsoft Word, for instance, it does one thing. It does word processing on Microsoft Word documents. But underneath, it does many things. So single responsibility is by scope. So you can have a subroutine, a sub-VI, for instance, that does one thing. You can have many sub-VIs that are used by a function, an API VI, for instance. And that API VI, or that function, again, just have a single responsibility and so on up the chain. A single software component that is a package. That package has a single responsibility, but underneath it does, when you dive down the scope inside it, it does many things inside. But on each surface of the component we're talking about, it's easy to understand that this component at this level does one thing. Your application has one role in life. System components and the system itself has actually one role. So that is single responsibility is easily understood. But how do we then achieve low cost and high value? Well, low cost comes primarily from reducing development cost. So prepare in advance, that is, for instance, reusing, and then try to develop solid APIs. They improve efficiency. And it's easier also for you as the primary developer to develop the first version if you understand the API yourself. It's like, they tie together, preparing and then doing solid APIs. Solid as in the solid principles. Then reduce downtime. That is also something that contributes to low cost. You have you can reduce downtime by having good code quality, and you have track-proven reuse components. That reduces downtime as well. If you can reuse a lot of code, that code has a tendency to break down less often than code that you just developed on the spot for this application. And that also ties into reducing maintenance cost. With single responsibility, narrows down what code you have to touch if there is a problem, or if you want to add a feature, or if the customer, that customer might be your colleague, it might be yourself in the future, requests something new. You can easily find out what code do I want to, or do I need to touch, and everything else you can just leave in place. It reduces greatly your risk of introducing new bugs in your code, and it reduces how much code you have to retest. Then high value. Well, if you have a reuse component, a reusable component, and you install a package, it also has additional features typically. If you're talking about string and array and more low-level stuff like that, error handling, time management, and so on. So you install an array package and you use one of the sub-VIs in there, and further down the line in your application, you also need to do something else with arrays. Well, you already have it at your disposal. Be careful not just adding a whole bunch of stuff. It really needs to be reusable stuff. So not just have that array package grow uncontrolled into a monster that has all kinds of features, because then you have a hard time reusing it or dragging around a lot of technical debt. Then the high value also comes from trustworthy code, because the repeated reuse of code allows you, as I mentioned, to spend much more time on development, and the higher subcomponents or the subcomponent quality is, the higher quality your entire application will be, and the higher value you get per minute spent programming. These terms or these points tie into at least or especially two different approaches or two different solutions. Three of them are solved by using packages, if we're talking about the LabVIEW IDE, VR packages, and two of them into code quality by itself. So those two topics are primary to achieving low cost and having high quality or high value of what you output as a programmer. So how to make high quality code? There are obviously many different ways, many different details to output high quality code. But a couple of points here that I have experienced is something that is more or less mandatory, and many people know, but fewer people do. The first thing is actually do it, because there are many people that knows how, or they might be able to say the right words, and also knowing what you should do when you get the time. But it's really important to do it all the time. Do the things you know are the right way to actually do something. I know it's hard to do it. It takes a lot of time, but there are ways to improve that with the right tools. So the first step is actually to do it instead of just knowing how to do it, and do it every time. And then do it right, get all the way to done, and maintain good coding practices along the way. And all the way to done, I mean, don't postpone writing VR descriptions. Don't postpone to make a refactorization of your code. If you find something that is truly bad design, change it right there. It's the least expensive time to change it, working around it and thinking you will get back to it later on. You're probably wrong. You won't, and you will battle this thing you didn't do for a long while. So do it right. Do it right in all steps. That is actually a huge time saver. Design for reuse. So at the moment you realize that you can reuse this, or you might even start a task that is for proper reuse, then design for reuse. And that is not picking out an old project, copying that, and that starting point is the worst kind of reuse. The only thing you can be sure of by copying from an old project is that project was never designed for what you're sitting with right now, because you didn't know anything about your future projects. So you start by yanking out stuff that was proprietary for that old project and maybe breaking stuff along the way, and then you end up with something that should actually have been the reuse component from the start in the best case. So that's some of the most unstable code, is starting from a copy of something old. Do it consistently. So if it's hard, then use templates and wizards. Once you have done stuff a couple of times repeatedly, then it's time for a template or maybe even a wizard to do it. It takes a while, but once you have done it, you can. We have wizards that helps us do stuff that took maybe 1 or 2 weeks. We can do that in 30 seconds now. That is a good kind of reuse. So and these, if you're doing a wizard, for instance, or a tool of some sorts, don't fall for the temptation to include all the bells and whistles. The future must pay for the future's requirements. So just do the least thing you can get away with, and if you do, If you do the software in sufficient quality, it will be easy to extend it later. So that's it here as well. Minimize complexity, actually. So a feature you are not implementing from the start or removing from your product or from your component is one less thing you have to implement now and maintain in the future. It is quite easy to get sucked into just also developing this feature and having that support and so on. Wait, unless you know that you will be using it in a moment. So wait with implementing it. And then at least, again, single responsibility is really important. What do we require from our packages? Well, a couple of things. I think there is 5 or 6 points here. One of the most important things is application code reduction. Let's say we have an application, a LabVIEW project of 1500 source file, a medium project. We could start over either with a copy or just from scratch and say, well, we have 1500 source files that we need to maintain. We must understand them and we must maintain these files. They have all different kinds of responsibilities. Or we could have some of these in reusable libraries via packages in this case, because we had them already on the shelf. So we don't have to include those in the application as custom for this application, even if it's just a copy. It won't maintain compatibility with what you copied it from. They have now divided their lifelines and will live their entirely separate lives. So reusable libraries via packages. By our experience, it's something like maybe 80% of applications. 70 to 80% of applications are the same stuff. Array, TCP/IP communication, XML decoding and encoding, stuff like that. And then even if the rest is custom for this application, some of it might have a single responsibility and should be developed as a package. A package that you can implement as a developer and then test, and it has its single responsibility, it has an API with a palette and so on. And then once it's developed, you can forget about it. Now it does what it was designed to do in your custom application. It might be even reusable later on, but it's not a requirement. It's still an isolated component of your application, developed and maintained separately from the application. And what remains of the 1500 source files is maybe 30 source files. Much easier to build your application, to actually add the required features, to review the application. So that is your main VI, for instance, and some utility VIs that does stuff, maybe some launchers and things like that. And those few source files, they just use a lot of independently maintained packages. This way you can much easier see what your entire application does and maintain it, for instance, and ensure the quality of it. So application code reduction is one thing. Actually, what is in your mind's eye when you develop the application? The scope of your application becomes much easier to oversee for the developer and for the project managers. Then we also need version flexibility. So we need to have major versions side-by-side installable. We need that to not force update requirements. Think if your application needs more than one component, one of them depends on dictionary version 1 and some of the other components depend on dictionary version 2, then because you need version 2 installed, you're not forced to update all the other components to use that as well. So that's a requirement. We must have these major versions side-by-side installable. And to avoid cross-linking accidents, or what should we call them, we need to be able to open our source code together with the installed libraries from the packages. What is installed in VI-lib or different places may not have name collisions with each other. That is also a requirement. But it's somewhat hard to just rename a library because a lot of stuff links to each other when you do this renaming. Then we need some features from our package folders, from our source code that goes into these types of packages. We need custom library errors. That's a topic entirely for itself, but we need that, for instance. And then we need a separate place for menu entries, the tools menu and other places like that. That is to be able to reuse easily the via package build file what goes into the menus. And then we need a package configuration. That is in this case package CFG. And then we need a build configuration. So the package configuration is, let's see if I can. Where is this? Here. Examples. Version is, how is this package configured? Well, these are package attributes, package name, author name, version, and so on. But then we also have a build configuration. How should this package be built? For instance, there might be files in your source that shouldn't go into the builds themselves. It could be documents, it could be basically stuff that shouldn't go into your final package. That should be included in no copy section here. Files that shouldn't have modified their descriptions. They might be templates. Stuff that shouldn't have modified their debug settings for some reason. Stuff that shouldn't have set or changed their password settings. And then test items. Our package build tools will automatically identify a lot of test items that it can include or not include. But if you have something specific that won't be identified automatically, for instance, if it's Caraya, the NI unit test framework, then you can add it here, paths to files and folders, and maybe package dependencies. Yeah. And then we also require build source traceability. So when we create a build, this is the source. This is the source of a VI package, and then when we create a build, it goes into the builds folder with a build number, and that build folder will include two things: the build source itself, which has been configured for this actual build, and then a build output created from the VI package builder. That's the VIP file. So that means if we have some sort of problem with this exact build, we can go and have a look in the build source and see what actually went into that build, instead of having to look around in the source itself, which may contain a lot of other things. So, and then we need automatic source code and palette.
Stefan had a question actually. Are major versions then actually just different packages?
They are all different packages, like in installed packages. And let's, yes, I can probably show here. Could that be? For instance, here is an example of some of our repository. And let's see. For instance, data is version 1.1. It has different builds. And if we look at then string, we have string version 2 here. That's one package of different versions. And then we also have GPower string. No, it's not in this repo. So, but then string version 1 would be a different name package. That would be string v1 instead. So yes, major versions are entirely different packages. It's also an entire different library. So the LabVIEW namespace will be different from those two. I'll show in a moment how it creates those, or how those are created. So automatic source code documentation. So we have the VI description, but some attributes are added to the VI description, so it's easier to see in your source code what package you are actually using here, instead of trying to look in via package manager or somewhere else what is currently installed. You can see exactly on your block diagram which version is it I'm using now for this exact VI call. Then context help for the palettes is also automatically generated. So other selected requirements are that we need to create a new package, a new version, a new build, and also a copy package function, where you can start over with a new package, but copying all the palettes and the VI package build specifications and all the source code, but having these potentially a new name for the package, and it starts over with version 0 or version 1. And then we need some build configurations that are hard defined by us: a debug build and a developer build and a dependency build. We mainly use the debug and developer. The main difference between those two is debugging allowed or not. Does it have some kind of password protection for the developer or versions? It still, in both cases, it still has all the menu items traveling along with them, and it has all the function and control palettes. The difference from these two to a dependency build is that all these developer features are removed from a dependency build. So all the reuse VIs are still in the package, but no palettes for the IDE and no menu tools and so on. So those could be installed and you can see them in your IDE, but you can build your application if you require that. And then build for. Who is this built for? Who is the author? And then in our case as well, we need a customer. If there is no customer specified, if you use this, then you may not define a customer. Then all those places where customer name will be put into your documentation and your source code, that will just be replaced with the author name. And then also an open source license option. And then we need to signal if this is a beta release or a release maturity build. Along this work, creating the actual build configuration of a package before we build it with VI Package Builder. About 130 VIPB fields are automatically configured. It was quite difficult to actually make packages that behave the same between developers. Even as myself, I couldn't make the same package build configuration from one package to the next, because there was always stuff I missed. Then some of the destination folders or something like that wasn't configured correctly. And then automatic handling of unit tests, debug flags, palettes, and passwords, etc. So the interesting part is, how do we do that? We have a tool called VI Package Assistant. This is an internal version. We are working towards releasing this for public use as well. It will look almost like this, but with some of the configuration files being configured from this wizard or from this tool, instead of configuration text files that you have to remember how to configure. And this gives you the ability to make new packages, new versions of a package, a new build of a version, and copy packages. So all we have to add after we use this tool is actually just the package description. Obviously, the source code as well. The tool can guess what VIs you want to put into it, but the package description and then palettes, configure palettes. Dependencies at the moment, you need to point those out, pick those out yourselves. That will probably be auto-calculated at some point in the future. So let me see if If I'll just demonstrate how it works. Here we have just an empty folder without anything in it at the moment. The current version of VIP Assistant is just available through the Tools menu. Let's see, we open it here, go away. So we just, to create a new package, we just have somewhere it must live. In this case, just on my desktop. Reduce this one in size a bit. So here, an author name, I'll just type GPower, and package name, my package. It's just a template for a folder structure on your disk in this case. Create new package, it will become available here. And inside it, we have a version 0.10, that's our initial version, which has a builds folder and source with a library in it and some template files, also of the package build specification here. I can just show what that contains at the moment. The only thing you yourself need to enter here is the description of your package and then set your palettes. What do you want in your palettes here? There will be some changes to what these palette sets include in a version that will be available to you. That's basically it. If you do that, instead of remembering everything you need to set correctly in the build specification, this tool can do that for you. And then the library, as the question went a moment ago, this will then be the package name and major version, and this case source LabVIEW. If we create, I go out again to the my package folder, which has version 0.10. I can create a new version of that one. I'll just drag in what is my base version? What do I want to base the next version on? Let's say it's version 1.0. I can create that version. Then now we have a 1.0 version. And it would have copied, obviously, all the source code from the prior version, and it says which version it came from. Not here, in the version history. Version 1.0.0, it came from version 0.10, and when was it started, and so on. What are the changes? You can add multiple lines that are change for these changed nodes, and those will automatically be applied to the package when you build the package. We can create a new version, obviously 1.1, and so on. And then we can create a build of this package. What should be built? Maybe version 1.1. No customer name, that's just for ourselves. Want a release version in debug. Don't want to launch via package builder, and do that afterwards and create a new build. And then inside the builds, a version 1.0.1 build will be put in here. It's already created. And in that, we have the build source now reduced from the template and applied with the settings that the package assistant applies. It will have a library now that is no longer including the source version out here, and the major version will be set as well on the library. So that's basically it, and then you can copy packages as well. So that makes it a ton easier to create new packages. When we identify that, well, we want a package for this, we have some common functionality, you can create packages or a new package just with a click of a mouse. And you can create a new version of it, either a version that you roll up and down, same version number, major version number, or a completely new major version that could be installed side by side, as we see here with an example of string version 1 and string version 2. Those are side-by-side installable because the LabVIEW library is actually two different names. And that's fine. We sometimes meet the question, well, if version 1 and version 2 of the LabVIEW have a different namespace, well, they have because they have different names, then you have to replace the different call sites that used to call version 1 with version 2 VIs instead. And yes, you have to do that because these two packages are not the same. You will actually have to make the conscious choice of where do I want to use version 2 VIs instead of version 1 VIs. We have thought about making a library replace tool as well, but that will probably be further down the line. But yes, you will have to make the conscious choice actually to change to a different package. As long as those are version 1 packages that you just install and uninstall, you can just change it. Your application don't mind. It will still be v1 LabVIEW. So that is, let's see here. That is some of the things I wanted to show you today. The tool here, as I said, we're working on making that available to hopefully everybody. And along that line, or that will bring along with it a lot of our internal reuse packages. We need to find out how to distribute those. Yes. So basically, to go back to code quality, you're actually saving a lot of headaches when doing software. This is just an example. So, but saving a lot of work is basically only possible when your entire team is very important. Your entire team and leadership backs this up. So everybody needs to know why this is smart, why it's smart to not using this tool or packages, but why it is smart to actually working smarter. Your entire team needs to be in on it, and your leadership as well. And you understand why and how to do it, and then you actually do it. And if you don't know how to do it, or it's a lot of work doing it, if it's creating new classes or new packages in this case, then it's time to employ some sort of tool that you hopefully can get from the community or make it yourself, but you need to do it. And obviously there is, as I write here, there is no free dinner. It does take a lot of work, but that amount of work is less than not doing these things correctly, because you'll just pay for it in a moment. So, any questions? I'll just open the Teams again. So, any questions about this? This was just one example of how you could work with some parts of your work process in an easier fashion. When we discover or run into stuff that takes a long time, it's difficult to do it the same way, then we tend to template it and talk about the best ways to do it, and then make some wizards and some tools to actually automate the process. And it's not something that we have any, tough feelings about what we do today. We are prepared to change tomorrow and optimize. So that's just something that we need to realize. There is not just a single answer to a problem. It might be better tomorrow. But start with small things, minimal viable product, and then get something out over the steps and start working with it. Is there any questions along the way I missed?
Yes, in the chat there were 2 questions. Have you happened to end up with more than 4 versions of the same package? How do you mitigate such a threat? For
major versions, I take it. Not yet. We are at 3 for some of them. But it's actually, well, we have a It's we have a frequently asked questions section in our version document that treats this question. Well, won't I end up with 42 versions? I think we write there. Hopefully not, because that is all about major version 0. Use major version 0 to get to a point that is quite stable. You now have an idea of what this package is and should do, and then breaking changes will be rare after that. It will be quite a conscious choice.
And there was another question. How long did it take GPower to get to this place?
10 years, probably. Something like that. Well, it's quite difficult to answer in all honesty, because it's something that we do all the time. It's something that we improve, and this is just one step along the way. I think we will have even better tools going forward. But I started GPower with the intention of continuously improving the way we work with LabVIEW and with software. And so we have taken baby steps, and we continue to take baby steps along the way. We actually have a saying, or it says so on the GPower ways of working with software development and systems engineering, that we're working towards what we call TAO, the golden standard somewhere out in the future or out in the horizon. And it's not that important how big a step we take towards that place, but it's important that we at least take a step towards that place whenever we improve something. Might be some deviations, because there is also a reality out there, but we know where we're going and where we're heading. So we're always moving forward, or try to. So it will take a while.
And 2 new questions have come since then. What would be the benefit of using VIPM packages instead of simple PPLs and artifact space?
Well, PPLs are not a substitute, I think. PPLs, we're using those for deployment, for instance. So PPLs might be built from something that are VI packages. So different tools or technologies for different applications. VI packages are really good when you are talking about the LabVIEW IDE, because they today support palettes. They know about LabVIEW versions. VI Package Manager knows about LabVIEW versions. So you can install the same tool for different LabVIEW versions. It understands mass compile and stuff like that. PPLs are, well, today they are more version independent, but we tend to use those mostly for deployment scenarios, where a lot of the benefits of PPLs are apparent. A single file, they can now be supported by a runtime engine of different versions, this epoch scheme. So I think that's PPLs by themselves do not lend themselves to have palettes included, for instance. You have to have a PPL built directly for a target and a business version and so on. So where VIs in VI packages are source code. So 2 different tools for 2 different things.
And next question. Is the build step where all the help descriptions get updated?
Yes, the build step is where the descriptions get updated. So that is where the actual build configuration is applied. So you can make different builds of the same source. The source for a package is the single source of truth, and you can make different types of configuration and then build some versions of that. That will be the build number that signifies that. The major, minor, and patch will be what package is this actually, and what specific version is it, and then the build number will signify, together with its documentation in form of a build specification, what configuration is this build.
Okay, thank you. And are you really using palettes?
Yeah, we do that. Those are great for those are great for discovery. for documentation, and for grouping, and know what family of functions are these. So yes, we use palettes for a lot of things. One example, yeah, it's easy to discover that way if you have some string functions, for instance, or some timing functions. Well, they have a cousin right there next to it. And these sub-palettes and so on, those are for data framing, those are for encoding of something like that. So yes, when we use Quick Drop, a lot of that discoverability and a lot of that actual documentation by topology goes away. But Quick Drop, when you know what you need, is a great tool.
I have another question, Steen. Do you have a strategy for helping both your team members, but especially your customers, know about which tools are out there and not reinvent the wheel when there's already stuff in your reuse libraries, seeing as there are so many of them?
Yeah, well, not really. We have used these tools internally, and just I think the last 1 to 2 years have started to share more of them with our customers, and as I said, would like to share more of them with the community as well. So we have just started to tackle this because internally we can talk with each other. We have release notifications, for instance, but in all honesty, I'm working towards an improved workflow for having our developers and users get to know when there is a new tool. We have made some tools that will live in the system tray that will notify you when something's become available in a repository. But for that workflow to be really good, I think we still need a few of the details in place, and we'll work with JKI, for instance, and all of the community to understand what are good ways to get these kinds of tools distributed. So internally, when we can handhold it, yes, it's easy, but in a wider distribution, we'll need some better tools.
And another thing that I'd be interested in is when you actually do the builds, is it something that somebody triggers manually somewhere on their machine, or is it kind of a like CI kind of thing, or how do you do that? How do you use it?
Currently, it's a manual thing. It's triggered by issues committed to Jira, and then there is a feature request, or there is a bug report or something like that, and then a developer or me, I'll get assigned to make an update, make a new build, and that build will then be published. When these versions of these packages are more stable, but they might have existed for a long time, or maybe even going into a product or an application that is the same kind of application all the time, then we'll be looking at how this could work together with continuous delivery. Continuous development as well. But at the moment, a manual process.
Is it? I know that's now very subjective, but is it very tedious to create new builds? Is it a lot of work? Does it feel manageable?
Yeah, it's really manageable. One example, if we go from version 2.0.0, I did that the other day with a string package. That was our array package 2.0.0 to 2.0.1. That is a patch that had to be applied, not a build, but a patch. It was 10 minutes. We had a bug report, fixed that VI, ran the unit test on the source, and could build a new version with this tool very, very quickly. So and we can build 2 versions. A debug version also has the testing tools installed with them, so they can be run on the installed package as well. And then the developer version strips those debugging capabilities and testing capabilities from the package. So we can just use that afterwards.
And I take it that you're using private VI repositories to distribute stuff?
At the moment, private repository, and that is also some of the things that one of the things that that we would like to improve on when we go wider with this. So and understand actually what would be the best way to publish this. That could maybe even improve the workflow internally at GPower as well.
Okay.
So Roman says,
okay. Sorry, it's okay.
30 custom VIs plus a dozen VI packages. How do you handle dependencies in CI pipeline? Well, currently we don't. But it is easier, I'd say, to handle these dependencies in, for instance, what could be a VI package configuration file. We don't use those a lot at the moment, but it could be a VI package configuration file or basically just a list of dependencies. But I'd say that it's a lot easier than handling, in this example, 1,500 source files, because those tend to be not compatible for very long at a time. So yes, but something along the way of a VIP configuration file. So, and when we will see this tool available and have the ability to or a chance to try it out, it will probably be something that can be improved in a lot of ways. And then we look forward to hearing if somebody can use it, finds it useful, and I'm sure there will be a lot of ideas to improve the workflows.
Yeah, you can rest assured that you will hear lots of opinions on that.
Yeah, definitely. So,
okay.
Yes.
Okay, any more questions, guys, to Steen while we have him? It seems we've covered it all. Thank you so much, Steen, for sharing all this. And of course, we'll be, I'm sitting on the edge of my seat already waiting for this to try it out.